Hey, what's up, guys? Welcome to day 4. We are going to be shifting topics just a little bit, but they are connected. If you will remember last time, we were looking at find how to model the distributor property using the area models, right? And so if you remember last time, we found the area of this one, this rectangle, then found the area of this rectangle, and then added them together. Well, we are doing the same exact thing, but this time our figures aren't just side by side like they were with the area models. Instead, this time we have different types of shapes. So we have what is called a composite figure, and that just means that it is made up of multiple other shapes. But what you'll see is you have a rectangle here, then you have a rectangle here. And so what we will be doing is similar to where we left off last time, but it is a little different. And it's different because there are going to be many other shapes that are involved, not just rectangles. We're going to deal with triangles. We're going to deal with circles. And so the first thing I want to encourage you, as you are doing any problems that involve the area of composite figures or area of any figures for that matter, you have this handy dandy formula sheet, all right? And so the formula sheet is what you should use in order to know which formula and what is the formula, okay? So when you are taking any tests, namely the SOL, you will have access to this. So you don't have to worry about memorizing the formulas, but you certainly want to always have this sheet available to you and have it to reference whenever you are doing these type problems, all right? And so I have provided just some steps, some guidelines to help you as you are finding the area of composite figure. Again, a composite figure just means one figure that has multiple shapes, right? It's kind of a irregular shape, right? It's not kind of your normal or traditional shapes, all right? So the steps are as follows. First, we're going to take the composite figure and we're going to divide it up into individual shapes, all right? And so if I have a big figure, right, say it looks like an L, I'm going to divide it up so that I have 2 rectangles. So that's step 1. Step 2 is I then am going to find the area of both of my pieces, all right? So after I've divided the shape up, I'm going to find the area of both. And then I want you to ask yourself, now sometimes you're going to be adding those 2 areas up. Sometimes you might be subtracting them because it might be a figure that's an area that's shaded and you're trying to figure out what's the shaded portion of the figure. And so you really got to understand the context of the problem and what it's asking you. But you do need to ask yourself, okay, do I need to add these areas up or do I need to subtract them? And then the last one is just to label and to circle your answer. So to label with the appropriate units, and I'll show that today, as well as circle your answer, because what I'm going to tell you is when you are solving these problems, they are multi-stepped, okay? These are not problems that you can just answer after with 1 or 2 steps. In many cases, it's going to take 2 and 3 and 4 steps. And so perseverance is going to be key, my friends. You are going to have to persevere. It is not that any of these problems are hard, but it will require you to do a lot of steps, all right? And so organizing your notes and what the different steps is and what the different formulas are and what the dimensions are. There's going to be a lot to this, but I'm confident that you can do it if you are not lazy, all right? So if you put in the work, then you will certainly be able to do it. All right, so enough talking of an intro. Let's get down to business, all right? So first thing we need to do is we need to take this figure and we need to divide it up into individual shapes, all right? And so what I want you to understand is there are multiple different ways that we could divide this shape so that we have 2 shapes that we know. You could divide it this way or you could divide it this way, right? And what you are going to find is regardless of how you cut it up, you are going to, or divide it up, you are going to get the same answer. Okay, and so for me, I am just going to divide it here, right? And if I had just an ample amount of time, I'd show you both, but for the sake of time, I'm not going to do that. And so when I do that, I now have a rectangle here and a rectangle here, okay? And so I'm going to refer to my formula sheet and figure out, okay, what is the what is the formula for the area of a rectangle, right? And I know that is area equals length times width, all right? And then that's figure 1, and then figure 2 is also a rectangle, so area equals length times width, right? And so now I've got my two formulas. Now I got to figure out what are my dimensions, okay? So I'm figuring out what are the dimensions of this first rectangle, and it is length times width. So my length is 11 centimeters times the width is 23 centimeters, okay? And then I'm just going to multiply 11 times 23, and I'm going to just pull out my Desmos calculator here. Again, I want to encourage you, all right, to use it. You don't have to try to figure that out. So 11 times 23, that gives me 256, and 256. And whenever you find the area, it is going to be centimeters squared, okay? So that is the area of this first one, this first rectangle. Now I'm coming over here and I'm finding the area of this second rectangle. So this is, all right, and then actually, sometimes I like to just put what I found right in each of the rectangles. Now I'm finding the area of this second one, all right? And then it's length times width. The length is 8 centimeters times the width is 13 centimeters. Okay, I'm going to multiply 8 times 13. And I get 104. So 104 centimeters squared. And again, the reason that's centimeters squared is because it's centimeters times centimeters, right? And so you get centimeters squared. That's just the unit for anytime you're finding area, all right? It's always whatever the unit is squared, right? And so this is 104. And so then I have to I'm finding the total area. So I'm doing 256 centimeters squared plus, again, that's where I'm asking myself, do I need to add or subtract? Here I need to add 104 because I'm finding the total of both of those centimeters squared. And then when I add those up, I get 360 centimeters squared, and this is my answer. All right. So that's it. Again, so what we're going to do is we're going to continue on. But guys, that is essentially what the steps are. You divide the shapes up. You find the area of the individual shapes. You ask yourself, do you need to add or subtract? And then you add them together and get your answer. All right. Moving on. Let's do the next one. All right. And so next, this one, we have this house-looking figure, and we have at the bottom we have a square. Now, oftentimes you might have a figure that looks like a square, but it might not be. And the reason I know that this is a square, not because it looks like one, but rather because both of the sides are both 4 centimeters, okay? So the area of this square, the figure is a square, so therefore we're going to use the formula for the area of a square. Then we also have a triangle, right? And we have this dimension of the triangle, which I'll talk about in a minute, all right? So first we have a square. We also have a triangle. So then I need to whip out my formula sheet. So everybody should be looking at their formula sheet. Again, I'm looking for the area of a square and then the area of a triangle. All right, and I'm going to write those formulas down. The formula for the area of a square is s squared, and the s representing the side. All right. Then the formula for the area of a triangle is area equals 1/2 BH. Okay, and the B and the H is the base and the height, all right? So I'm gonna plug in my dimensions. So for my square, I have the side is 4, so it is 4 centimeters, 4 squared, okay? And again, that's 4 centimeters. If you want to put the A with it, you can. All right. So again, I just want to show you, you can plug this straight into Desmos. If I don't know how to square it, all right, I can put it really even with the A. I can put A equals 4 squared, right? And that gives me 16, okay? Just showing you what that looks like. So it is 16, and remember, it is centimeters squared, okay? So that is the area for the square. Okay. Now, for the area of a triangle, now here's the deal. I have one dimension. I need the base and the height. Well, the base is the bottom, right? But the bottom's not labeled. Well, sometimes you are going to have to use the information that you know that's given to you to find the other unknown sides or dimensions. Okay, so if this is 4, I also know this is also 4, and that is the base of my triangle. So I'm gonna take my formula over here, 1/2. The base is 4 centimeters times the height, which is height, remember, is always straight up and down. It's like how tall you are, right? 3 centimeters. And then I'm going to multiply those. Again, I just want to show you this is what I expect, right? You can use your decimals calculator. 8 equals 1/2 times the base, which was 4, times the height, which was 3. And when I do that, right, I'm going to get 6. Okay, so 6 is the 6 centimeters squared is the area of the triangle. So 6 centimeters squared. And so then I'm finding the area of both of these together. So I have to add them. So I have 16 centimeters squared plus 6 centimeters squared for a grand total of 22 centimeters squared. And that is the correct answer. All right. Okay, hopefully you're feeling like these are pretty straightforward. Figure out what shapes you got, figure out the formulas, and plug in the formulas. All right, this last one that we're going to end with here it's a little challenging only because we now have a circle in here, but we don't have the whole circle. We have a semicircle. We have half of it, all right? So I'm going to go ahead and tell you on the front end, if you don't have the entire circle, then once you find the area of the whole circle, what do you think you're going to have to do? Well, you're going to have to cut it in half, right? So that's the only thing that makes this one a little difficult. So, but we can handle it. So we have what, 2 shapes? This one's kind of already cut for us, right? Sometimes they will be, not all of them will be, okay? But we have a circle, okay? And I'm going to say that we have half of it, okay? Again, that's called a semicircle. And then we also have a rectangle. All right, so friends, I'm gonna start by, okay, I've gotten my shapes cut down, divided up into a circle and a rectangle, and I'm gonna go to my formula sheet. I'm just pulling this out again because I just want you to, we gotta reference this many times throughout this lesson. All right, so the formula for the area of a circle is A equals pi r squared. Okay, and then the area for a rectangle is area equals length times width. All right, now friends, I do want to point out again, the formula sheet, it tells you what the radius and the diameter are. So it's really important that when you are looking at this, right, it tells you the radius is half of the circle, the diameter is completely across. And the reason I point that out is because sometimes, right, if we look at it in this formula, we need to use the radius. But the diameter is the thing that's given, right? Because it goes from one side of the circle all the way to the other. So you are going to have to know that I need to cut that in half in order to find the radius, okay? So this is 6, but my radius, the diameter is 6, but the radius is 3, okay? So A equals pi, listen, we can use 3.14, or I would just say, using the decimals calculator, just use the pi symbol, okay? So I'm just going to use the pi symbol in decimals. And then the radius, again, it is half of the diameter. It goes from one side of the circle to the middle. So my radius is 3, and that's going to be squared. It's 3 feet, and that's going to be squared, okay? So I'm going to flip over, okay? I'm going to A equals, again, I don't have to put the A, but I want you to see that you can. Pi R times R, and R we said is 3 squared. So my answer is 27, and I'm just gonna round it to the nearest 100. So it's 28.27, okay? So we got 28.27 feet squared. Now, that is the area of the entire circle, okay? But we don't have an entire circle, we have half of a circle. So because we have half of the circle, I now have to take this and divide it by 2. And that is gonna give me the area of half the circle. So let me go back. Okay. And guys, that's gonna be something that you're just gonna have to remember. Okay. So once we do that, let's see if I can divide. Nope. Okay. I'm gonna take 28.27. I'm gonna divide it by 2. Okay. And then that's gonna give me 11.13. Okay. So I'm sorry, 14.13. 14, and then I'll round it up to the nearest 100, which is 14.14. Okay. So half of the circle is going to be 14 feet squared, and that is, again, for half of the circle. All right. Now, to find the area of the rectangle, length times width. My length is 6 feet. My width is 15 feet. Then I'm going to multiply 15 times 6. 15 times 6, which is 90. All right, and so I get 90 feet squared, and that is the area of the rectangle, so 90 feet squared. And then I got to add up these two, so I take the 14 feet squared plus the 90 feet squared. When I add those, I get 104.14 feet squared. And that is my answer for the area of that figure. All right. Hey, friends, I know that was, again, I did several examples, and these are the different types that you're going to see. Now, gonna say these next ones are, they are a little more challenging in that you do have to cut these up. They're not cut like the other ones, a couple of the other ones were. So I want you to start by dividing those shapes up. Again, please make sure you use the notes. So refer to, we have an example like each of these. So just refer to it, all right? And then I want you to pause this video, and I want you to attempt to do the remaining problems on your own, the remaining problems on your own, okay? So this is done, the end of the lesson, end of the lesson for the day. I am going to end up working out the rest of these just so you have them, but I want you to pause it, make sure you do the rest of them on your own, and then you can use the video to check if you need additional help, all right? Hope this lesson has helped you understand how to find the area of composite figures. Again, you're only using this part of the video to check your work after you have already worked these out on your own. All right. So, I'm cutting this up, rectangle and a triangle. Okay, so I got a rectangle. I got a triangle. The formula for the area of a triangle, of a rectangle, is area equals length times width. Area of a triangle is 1/2 base times height. The length, the dimensions of my rectangle is 6 inches times 10 inches. That's going to give me 60 inches squared. Now, the dimension of my triangle, it tells me the height is 4, because that's straight up and down. That's 4. I don't know what this is, but I know that this is 10, and I know that this is 6. So this also must be 4, because 4 plus 6, it gives me 10, okay? So the dimensions of the triangle is 1/2 times 4 inches times 4 inches, okay? And so when I do that, half of 4 is 2, 2 times 4 is 8, so we got 8 inches squared. All right, so that is 60, that is 8. So we add that up, 60 inches squared plus 8 inches squared gives me a grand total of 68 inches squared. All right, moving on. Next one, I'm gonna divide this up like so, okay? And when I do so, now I got a rectangle. I also have a triangle. Make sure you refer to that formula sheet. Area equals length times width. The length is 3 feet. The width is 8 feet. Do that, we get 24 feet squared. Okay, this is 24 feet. All right, now to find the area of a triangle is 1/2 base times the height. The base, now I actually don't, this whole thing at the bottom is 6. So if this is 3, then I know this is 3. And if the whole thing is 6 and this part is 3, then I also know that is 3, okay? Guys, this is the hardest one, where you have to actually use what you don't know, what you do know to find what you don't know, okay? But you can do this, all right? So that's how I figured out the base was 3. And then for the height, okay, this whole thing is 8. If I know this piece is 4, right, and it kind of stops right here, then that means that this piece is also 4, okay? And so therefore, the height of it is 4, right? Because it, again, you just think this goes from here to, and it stops right there. So the height is also 4. So we got 1/2 times 3 feet times the height, which is 4 feet, okay? And I'll do half of 4 is 2, then 2 times 3 is 6. So it is 6 feet squared, and that is for the triangle. And so then we do 24 feet squared plus 6 feet squared, and we end up with 30 feet squared. All right, we got another rectangle and another half circle. So we got a rectangle, and I'm gonna say half of a circle, or semicircle. All right, formula for the area of a rectangle is length times width. Formula for the area of a circle is 1/2 pi r squared, okay? The area for my rectangle is the length is 8 feet. The width is 10 feet. We get 80 feet squared. Let me write that a little better. 80 feet squared, okay? That's the area, okay? Now, for my circle, I know this is 8, right? Because this side is 8. But remember, this is the diameter, goes all the way across. We only need the radius, so we only need half of that. So the radius would be 4, okay? So we got 1/2, A equals 1/2 pi, then R is 4 squared, and that is feet, okay? And so I'm gonna go 1/2 pi changing that to 4. All right, and so we get 50.26. 50.26 feet squared. Oh, and again, that's for the whole circle. So what I gotta do, because it's only half of a circle, I gotta divide this by 2. And that's gonna give me the area of just that half of the circle. So we take that, we take 50.26, we divide it by 2, because I got half of the circle and it's 25 So 25, sorry, running out of room here, 25.13, that is feet squared, and that is okay. So then I add that up, 80 feet squared plus 25.13 feet squared. That gives me a grand total of 105.13 feet squared. All right, friends, almost there. If you made it this far, you're doing awesome. All right, now I can divide this up in two different ways. I could go here with it, or I could come down with it. I'm gonna do this way. Okay, again, it doesn't matter. You can do both. All right, and then I actually have a square here. I know that's a square because I'm looking at the dimensions. So that's a square. And then I have this one, which I don't know what this is, but we'll figure it out, but it is a rectangle, okay? So formula for the area of a square is A equals S squared. Area of a rectangle is length times width, okay? And so then for my square, it is 4 inches squared. Square of 4, and so so the area of the square is 16 inches squared. Okay, so that is for the square, and then I gotta use what I know to figure out the dimensions of this rectangle. Okay, so if I know this is 4, then if this is 4 and this whole thing is 8, then that also must be 4 inches, right? And again, I do that because I know this is 4, that's is 4, and it stops right here, and the whole thing is 8. Okay, so the formula, or so for the area of this rectangle, it is length. The length is 4 inches. The width is 6 inches. Multiply that, I get 24 inches squared. Okay, 24 inches squared, and so then I add them up. 24 inches squared plus 16 inches squared, and I get 40 inches squared as my grand total. All right. See you next time.